Let's talk about drawing chair conformations. Cyclohexane has two equivalent chair conformations, right? What we mean by equivalent chair conformations, it means that the chair conformation, the two conformations that we have, both of them have the same energy, right? Chair conformations and energy is dealt with in more detail in any of my videos dealing with chairs, the stability of a chair. All right. Here, your cyclohexane has two chair conformations. So let's talk about how you draw those two chair conformations. Literally, the chair conformation to go from one chair to the next chair is the chair is just rotated or flip or twist, whichever word you want to use, right? So to draw the two equivalent chair conformations of cyclohexane, this is all you need to do, right? You need to draw two parallel lines, not directly under each other, right? So in essence, you draw one line like that, and then the second one can be here, right? Um, then, I think I'm gonna move this one a little bit. Then the second chair, and you can't go wrong once you draw these lines. I promise you will get the two chairs, right? This is the second chair. So in essence, you draw two parallel lines, right? Not directly under each other, where the two lines here is pointing to your right, up, and these two is pointing towards my left, up, right? So if you draw those two set of lines, you get the two chair conformations without sweating, right? This is what you do after you draw the two lines. Where the lines point up, you connect those two lines with a V down. And I want to connect it with a V down, right? Where the two parallel lines point down, you connect them with a V up. That's one chair, all right? Then your second chair, which is the rotated or the flipped version of this chair, is drawn once you do the lines like this, I promise. So where you have the lines pointing up, both lines pointing up, connect with a V down. Connect with a V down. And where you have the lines pointing down, connect with a V up. And those are your two chairs, right? So if you look at your chairs, you will realize whichever word works for you. The chair, this chair, has been rotated this way or twist this way or flip this way, whichever one works for you, right? I'm gonna, so this is, I'm gonna label some stuff. It makes it easier for you. This is the nose of the chair, and this right here is the tail, or you could call this head. That right there is the tail. So if you notice, the head of the chair or the nose, right, is right here. Notice when the chair rotates and the chair rotates in this direction, your nose is now here, right? And the chair is going in this direction, right? I'm going to put some numbers in here in a second, right? But let's just hang out on the nose for a little bit. So it rotates. It's rotating in this direction. So in order for me to go from this chair, from one chair conformation to the next chair conformation, all that happens in order for you to get the second chair is that this chair rotated. That's it. So we have two equivalent chair conformation to go from one chair to the next chair. It's a rotation. And like I said, once you draw those two parallel lines that you have, that I drawn before, you will have the two chair conformations. So let us look at here, the nose here is what's here. Okay? Remember, the chair rotates this way. Let's put some numbers in. So this is, we're going to call this 1, 2, 3, 4, 5, 6. If you go to the alternate chair, right, the chair as a result of the rotation, let's talk about where carbon 1 here, this carbon 1 is now up here. Yes? Yes. So this is carbon 1. The rotation went this way, right? This way. So this has to be 2. This has to be 3. Notice our nose falls down. The chair is rotating all this way, right? So the nose, number 4, will fall here, right? And we're moving this way. So this is 5. And this is number 6. So these are the two equivalent chair conformations for cyclohexane. Now, you should notice by now we have a line angle structure. Okay? So the hydrogens are not shown, but I'm going to put them in because we need to be able to identify axial and equatorial bonds. All right? Axial and equatorial bonds, we need to be able to identify those. So I'm going to put the hydrogens in, and we're going to do step by step, right? And I'm also going to bring in a ball and stick in a second. So let me just erase this, take this out, and then let's play around with this chair, right? So I like to stay on the nose. It's kind of easier to see things, right? So let's talk about what an axial bond is. Remember, each one of these carbons they have hydrogens, all right? So let us put in our axial bonds, right? And we're gonna start with, I think I'm gonna use the chair on the right because the ball and stick that I have, it was made for the chair on the right. Now, something quick to tell you. If you're ever asked to draw a chair, they just want a chair. You can draw either one of these. It's fine, right? When we go into stability, we'll talk some more about um, chairs not having the same stability and drawing specific chairs. We'll get there. All right. So let us look at drawing our axial and equatorial bonds. Let's start with our axial. So the axial bonds, they point straight up, right? Your axial bonds point straight up. So axial bonds, they point straight up and straight down. They're straight up and straight down. Here's another trick. Your axial bonds, right? I think, what color do I want to use here? So we could have just still used red. Your axial bonds, they point in the direction where the lines meet pointing. So for example, if you look at these two bonds, when they meet right here at the nose, they meet pointing up. So your axial bond is up on this carbon. Let's move around. Let's go to carbon number 2. On carbon 2, we're over here. On carbon 2, right? The lines meet, if you look at it, the lines meet here and here. The lines meet pointing down. So your axial bond on carbon 2 points straight down, right? Your two bonds at carbon 3, the lines meet pointing up. So your axial bond here points up. This one, the two lines going towards carbon number 4 meet pointing down. So your axial bond here points down, right? Two lines at 5 meet pointing up. At 6, the two lines meet pointing down. So all the bonds that you see right now, they're axial bonds. All right. So your axial bonds, they point straight up or straight down. And notice, so this is your chair, or you can consider it your ring. These are above the ring. These are below the ring, pointing straight up. Above the ring, point straight up. Below the ring, pointing straight down. Here is something else to so that's the easiest way for you to identify your axial bonds. They point straight up, they point straight down, and wherever your bonds meet pointing, right, is the direction in which the axial bond will point. Now, each carbon in your cyclohexane ring has one bond pointing up and one bond pointing down. So each carbon, there's one bond pointing up and there's one bond pointing down. So we already put in our axial bonds, right? The bonds that are left over are your equatorial bonds, right? Your equatorial bonds, and I'm going to put them in blue. Your equatorial bonds, they hang out, they chill out on the side of the ring, right? So for example, on carbon 1, this would be the equatorial bond, and that's equatorial down. It has to be down because your axial bond is already in the opposition, right? And I'll show you on a ball and stick in a second. If we look now at carbon 2, or equatorial bond is up. It's up like that. Here it's down. So this is equatorial down. This equatorial down. This equatorial up. This is equatorial up. This bond is already down. So this is equatorial up. This is equatorial down. This is equatorial up. Okay. So your equatorial bonds are in blue, right? This is equatorial down. Sorry. It's equatorial down. This one represents equatorial up. Let's do something here. Let's bring up a ball and stick model. And it's good to always be able to see 3D, and you could better see the equatorial and axial bonds. And the truth is, you will get questions that will ask you to identify axial and equatorial bonds on a ball and stick. So you need to be familiar with this. You could also get compounds to name ball from a ball and stick ring structure. So you need to know what they look like. So let's make this bigger. All right, let's tackle this now. So let's see if we can identify the carbons here, right? So I'm going to match up the carbons and hydrogens with, from my 2D structure up here, with the ball and stick. So this is my 2D. This is my 2D, all right? And this right here is my ball and stick. So let us identify some things, all right? So first, let us find carbon number 1 on my ball and stick. This is carbon 1 on your ball and stick. This is carbon 1 in our 2D. Let's talk about some things. Notice this part of the ring goes up like this. Notice this part is up like that. This carbon is carbon 1. Then if you notice, this one dips down. What dips down here is 2. So carbon number 2, this is carbon 2. Clearly this is 3. And then remember 4, carbon 4, I like to be at the nose, dips down. So this is 4 dipping down, 5 up, 6. All right. So those are, so this is your carbon 1 from your structure, from your ball and stick. This is carbon 1. This is carbon 2. That's carbon 2. 2 bonded to 3. This is 3. Drop down, that's 4, 5. This is 5. This right here is carbon number 6. That's 6. If you look, you see it. You'll see here it went up, right? And if you also look in this direction, it dipped down. Then carbon 5 went up, right? See that 5 went up? 5 went up. Let's talk about the axial and equatorial bonds on here. You should be able to see it even better now. So we said on carbon number 1, the axial bond points straight up. This is the axial bond, right? This is our axial bond, and this is the equatorial bond. That's down. So this is up, down. So here we have axial bond that's pointing up, equatorial bond that's pointing down. If we move over, I'm going to go to carbon 6 because I want to show you something. On carbon 6, right? Here's carbon 6. This is the axial bond, I'm sorry, pointing straight down. And this is the equatorial bond pointing up. Let's go to our molecular model. This is the axial bond. And this right here is your equatorial bond that's up, right? So let's do a comparison here so you're able to see this. An equatorial bond down looks like this. An equatorial bond up looks like that, right? And I'm going to use 4 and 5 to highlight the equatorial again. So let's find carbon 5 here. This is carbon 5. This is carbon 5, right? This is our axial bond on 5 on the molecular model. This is your axial bond here on carbon 5 in the 2D. Your equatorial bond, this is your equatorial bond. This is your equatorial bond here, right? This is equatorial down. So this is equatorial and it's down. Over on carbon 4, this is our equatorial bond. Notice it's up. Here you have your equatorial bond up and your axial bond down. So I wanted to show you, look at this. This right here is your equatorial up bond. This is what your equatorial down looks like. So that's up, this is down, right? Let's look here. You can look at it. This is when it's pointing up, this is it's pointing down. And what will help you sometimes is look at the axial bond. Like just take a look at your axial bond, right? This is the axial bond. It's pointing straight up. So this is down. It's below the ring, all right? Or below the chair. If you go over here, this is down. This is pointing up. So I wanted to show you what an equatorial down bond look like and what an equatorial up bond looks like. So always remember for your chair conformations, the two chair conformations for cyclohexane is equivalent. That's because they have the same energy. Okay. Um, if you want to draw the two chairs, just draw the two parallel lines that I drew in the beginning. You can't go wrong. Once you draw those two set of lines and connect them with the V up and down, boom, you got your two chair conformations, right? You need to know how to draw those two chairs. They will come in handy in a couple in when you start doing chair stability, when you start looking at if two things are conformers or steroids, you have to be able to draw these two chairs. And it's easy, just draw the lines, right? Just draw the lines. Here, these are hydrogens. Sorry, I didn't put them in. These are hydrogens, hydrogen, hydrogen, hydrogen. So you should remember your axial bonds. And let me show you your three axial bonds here. These three are your axial bonds, right? Let me your three axial bonds at the top of the ring is this one, this one, this one. So these are your three axial bonds at the top of the ring. So you also have three axial bonds pointing straight down. This is one, this is two, and this is number three. So these are the axial bonds that are in your everything else that is hanging off, and I'll give it red. These are your equatorial bonds. They hang off on the side. They point up and down, yes, but they chill out on the side of the ring. That's how you draw your cheer conformations.